Before a building can be erected, and before a slab or strip footings can be poured or piers constructed, the external dimensions of the building must be transferred from a set of plans to the site and correctly located with regard to front, side and rear boundaries. This procedure is known as setting out. Local council approval is necessary before construction can begin. Sometimes other authorities also need to give their approval. A check should be made to ensure plans are stamped and dated to indicate approval. It is good practice to become familiar with both the site and the plans before setting out commences. Plans typically contain 4 elevations, a section, a floor plan, and a site plan. The relevant information for setting out is found in the floor plan, which gives the perimeter dimensions, and the site plan, showing distances from boundaries, any existing buildings, and main services. The first step in setting out is to locate the survey marks for the building block. These will have been established by a registered surveyor to define the exact boundaries or outline of the block. On a new block, they are easily found. They are usually 50 mm square wide pegs driven close to ground level with a nail in the top. Measurements are made from the head of the nail. On a developed block, a survey mark can be more difficult to locate. It may be a peg, or it could be a nail in a fence post or a mark on a concrete path. It is unsound to use a fence line as a datum from which to start measuring. Fences are not necessarily a true representation of a boundary. With survey marks located, a quick check of actual boundary measurements can be done to make sure they match the dimensions given on the site plan. Buildings are often located parallel to one side boundary at a specified setback distance from that boundary. A second setback from the front or rear boundary is needed to site the building. The combination of the 2 setbacks fixes one corner of the structure. The side boundary is established as a datum or starting point by running a string line directly above the 2 survey marks at the corners of the block. This boundary string line is fastened to pegs driven into the ground behind the survey marks. The string is plumbed to the marks to make sure it lies vertically above them. The boundary from which the second setback will be measured, in this case the rear boundary, is pegged out with a string line in a similar way. An adequate supply of pegs, string lines and profile materials should be on hand. Profiles are pairs of pegs driven into the ground with horizontal cross members fastened to them. The cross member or ledger allows sideways adjustment of string lines during setting out. Where the ledger is fixed to the tops of the pegs, a profile is called a saddle. Where the pegs are longer and the ledger is fastened to the sides of the pegs, the profile is called a hurdle. The longer legs allow the height of the ledger to be adjusted up or down during levelling procedures. It is good practice when using a hurdle to have the tension string line pull the ledger against the pegs rather than away from the pegs. Accuracy is extremely important in setting out. Accurate set-out measurement can only be achieved on the level and not on an incline. This means all string lines, and therefore all profile edges, must lie on the same level or horizontal plane as setting out proceeds. On most sites, it is necessary to find the high point of the ground on which the structure will actually sit. Before this can be done, the approximate location of the building needs to be established. This can be done by inspection of the building block in conjunction with the site plan. A quick measurement gives the approximate location of the corners of the building. This gives an overall idea of the job. A levelling procedure gives the highest point of the ground covered by the building. With the automatic level set up, taking some preliminary levels locates this high point. A height peg is placed here for reference. The top of this peg is a datum for the height of brickwork, which allows for minimum clearance to the underside of bearers. Or in the case of a concrete slab, the reference mark is the top surface of the slab. Working from this established height, profiles can be erected with ledges levelled in the one horizontal plane. This initial height peg procedure is needed because the first profile setup will not necessarily be at the high point of the site. The side of the building parallel to a boundary is set out first. With the approximate siting of the building as a guide, a pair of profiles is set up to carry the string line for this first side. To allow ease of working and access for machinery, profiles are placed at about 1 or 2 metres outside the line of the building. A measurement to the top of the height peg is taken. This can be done using a staff. A more convenient way is to mark the height on a batten.
Up 150, up 20, up 5, steady, that's it.
This height is transferred to the legs of the profiles.
Bring it up 20, up 10, too far, down 2, down 1, spot on.
The tops of the ledges are fixed at these marks and levelled across the profiles. The side setback distance indicated on the site plan is measured square off the side boundary string line to each of the 2 profiles. Greater accuracy is achieved by measuring from the metre mark rather than the end of the tape and then adding 1 metre to the final measurement. These measurements are marked on the tops of the ledges and nails located on the marks. A string line is fastened between the two nails and tensioned. The rear setback is measured from the rear boundary line back along the string. This measurement locates the corner of the building. A peg, here called A, is driven into the ground at this point so that the head of the peg is just under the string line. The exact position of the corner is marked with a nail driven into the peg head. The length of this side of the building is measured off along the string line and the second corner B pegged. With one side and two corners fixed, the other sides and corners can be set out by the application of one of the 3-4-5 methods of producing a right angle. Using the already established side as the base of a triangle, measure 3 units, say metres, along the base from corner B towards corner A and peg this point, here called X. A metal tape set at 4 metres is anchored at B and a second tape set at 5 metres is fixed at X. A peg, here called Y, is driven in at the exact point where the two tapes cross. Any triangle with sides of 3, 4 and 5 units will have a right angle at the corner where the shorter 3 and 4 unit sides meet. A string line is run from the nail in peg B above the nail in peg Y and tensioned. This produces an angle of 90 degrees at peg B. A profile is then set up and the string position marked. An alternative method to establish a right-angled corner is to use a builder's square. This consists of 2 timber arms fixed at the corner and braced to form a right angle. When placing the square at a corner peg, at least one of the arms must be level to produce accurate results. The larger the builder's square, the more accurate it will be. One arm is sighted to the existing string line. The second string line is run parallel to the other arm of the square. This produces a 90-degree angle at the corner of the building. There is, however, another method of setting out the third corner peg. This procedure has the advantage of eliminating intermediate steps, such as temporary pegs and sighting of string lines. It locates the third corner directly. A 3-4-5 triangle is a special instance of Pythagoras' theorem, which states that in any right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Or, AC squared equals AB squared plus BC squared. By substituting the lengths of the two sides of the building, which are known from the floor plan, for AB and BC, the length of the hypotenuse AC, that is, the diagonal measurement of the building from corner A to corner C, can be calculated. The first part of the calculation gives AC squared. In this case, 87.84 metres. To find AC, it is necessary to find the square root of 87.84. The answer is 9.372, which is the actual length in metres of the building's diagonal. The two-tape method can now be used from the established corners of the building, pegs A and B, with true building dimensions. Using actual building dimensions locates the exact position for corner peg C. With peg C in place and levelled, the diagonal AC measurement can be accurately transferred to the peg. The side measurement BC is also transferred.
Right.
Where the measurements intersect is the exact position of the corner of the building. With the third corner set out, the procedure is repeated to peg the fourth corner, here called D. This corner peg is again levelled to the same horizontal plane as the others.
How's that?
Down 20, down 5, oh, spot on.
The second diagonal BD measurement and the side AD measurement intersect to locate the fourth corner of the building. Measurement of the closing side, CD, is made to check the accuracy of the set out. Pairs of profiles are set up for the three remaining sides and the ledges levelled to the height peg reference mark. Once again, profiles are placed 1 or 2 metres outside the corner pegs to allow workspace for materials and machinery.
Down 50. Whoa, that's good.
One string line for each side is pulled over the nails in the corner pegs and fastened to nails in the profile ledges. Because all ledges have been levelled to the same height, the 4 string lines accurately set out the perimeter dimensions of the building correctly located on the site with the required setbacks. Not all buildings, however, are rectangular in shape. In setting out L-shaped or T-shaped buildings, the first step is to peg out the overall rectangular envelope that contains the building. Part or parts of this rectangle are removed to form the L or T. These cutouts require additional profiles to be set up and levelled.
Up 5, whoop. That's good.
The new profiles are placed in line with the existing ones. Cutout measurements can then be made directly from ledger to ledger on profiles. String lines join these profiles to create the cutouts in the outline of the building. With all string lines in place, the external perimeter of the building is accurately defined in the one level plane.
Up.